So, the radius of the ripple was r of t equals 0.6 t, and so the circle of the ripple was a of r equals pi r squared. And so the a of r is the area of the ripple, but you don't know the radius, so you have to find the radius with the second equation. That's why you put them together. And then when you put them together, you get pi equals 0.6 t squared, and that's pi 0.36 t, and then 0.36 pi t squared. And then number 2 was so it would be the number of bacteria as a function of temperature as a function of time, or when the when the number of bacteria is unknown and the temperature is unknown, but the time is not. So for B, you would just put in 2 for T because it's 2 hours, and you would get end up with 1,700 bacteria, which is a lot. And then for C, you would set the equation equal to 2,000 and solve, and then it would be equal to plus or minus 2.22, but it has to be plus because you can't have negative time, so it's 2.22 hours.
Virginia, do you mind leaving that up there? Nice job. I'll talk about that second one a little bit. Nice job. So this part right here, oh, here it is. That part there is the composite function. So for the first question, it says, what is the composite function? What does it mean? So when you have n of t, I thought you were hanging out with Brandon today, Chelsea.
Oh yeah, you know me.
When you're finding n of t, I know there are 2 t's there. Like that was the whole getting you to kind of think of what it means. So n is the number of bacteria. Upper T, uppercase T, is temperature. Lowercase t is time. That is no different from finding f of g of x. It's just we're switching the variables to represent time and temperature, or temperature and time. So if you take the time temperature function, that is the 4t plus 2. You're plugging that in for uppercase T in the number of bacteria function, which is exactly what she has right here. So you have the 20, and then the time with respects to temperature is 4t plus 2, minus 80, 4t plus 2, and then plus 500. Like that's the composite function part. So if you're finding the composite function, you're taking the 4t plus 2 and plugging it in for the number of bacteria. And then as she said, this should be 2.22 hours. It's positive because you can't have a negative amount of time. So the first number, the 1700, represents the number of bacteria, which would be in your food. So like you think about, this is kind of gross to think about, but if you're at a picnic for like the 4th of July, Labor Day, Memorial Day, somebody's birthday over the summer, maybe your grandmother's 75th birthday. And there was all that food sitting out that came out of a refrigerator. So your potato salad, your pasta salad, maybe macaroni salad, deviled eggs, fruit salad, coleslaw, ranch dip for your veggies. And none of it is chilling on top of ice. It's just sitting outside. The warmer it is outside, the quicker the temperature of the food that was cold in the refrigerator increases and it gets warmer. And as that food increases and it gets warmer, the number of bacteria in your food also get larger. That's what this number here, the 1700, represents the number of bacteria that are in your food after 2 hours. So you go to a picnic, you eat the food 2 hours after it's been sitting. You now have just consumed 1700 bacteria. Yum. So imagine at the end of the picnic and it's at your house and you're helping mom or dad clean up and you're still munching on the ranch dip. Think how much bacteria you've just eaten, which some is good, right? And like yogurt is okay. Yogurt has good bacteria in it. But like that's what that problem is talking about. So like real life application. Now maybe you don't go to the picnic and think about the number of bacteria you're eating because you don't want to think about that. But that's what this problem is kind of talking about. So after 2.2 hours, you've consumed 2,000 bacteria in whatever food we happen to be dealing with that was in the refrigerator that's now come out of the refrigerator. So not talking about like something that was grilled, so like your grilled hamburger, your grilled hot dog, but this is like food that's supposed to be in the refrigerator that's pulled out and it's sitting on the picnic table. Everybody wants to go to a picnic now, right? So eat the food first at the picnic. Don't wait and like don't come 5 hours later, unless it's in like one of those big coolers, big buckets of ice sitting on top of ice. You're good to go then, pretty much. Grace, what do you think? Does it gross you out just a little? It's okay to eat bacteria though. Like good, there's like good bacteria. You want to have some of it in your body. Maybe just not a whole bunch of it in one setting. But we all do it. Questions? I still need to hit this group over here. Are there questions on those 2 word problems? Regina did an excellent job kind of explaining those. So applications of composite functions. Like the goal was just to get you to kind of think of those composite functions, one function getting inserted into another, what that means with respect to an actual like concept instead of just saying a crazy function that we're just taking. These are actually applying it to something. Thank you. Could have looked at my sheet too. So if I already looked at your page, in your packet, if you could flip to page 40. And at the top of page 40, if you can work through that warm-up problem, dealing with composite functions and inverses. So we're not really doing anything new today. We're just going to do some applications of composite and inverse functions. I'm guessing you didn't get something to cancel.
Yeah.
I think it's your multiplication.
Yeah.
Right there. Just reading through each one. Virginia.
Yeah.
That number. Isn't it?
Yeah, I was like, I couldn't.
That's all right.
Yeah, and I
I know.
couldn't find
It's the
it.
same. Yeah, I think she multiplied 8 times 4 and got 240 this morning. So you just got 340.
Yeah.
That's happens. So page 40. Just kind of looking ahead through the week. A couple assignment sheets up here if you want to grab one later. Tomorrow we're going to review for your chapter 1 test, which is on Wednesday. Thursday. On Wednesday, we'll take a few questions again for the chapter 1 test on Thursday. And then we're going to talk a little bit about completing the square on Wednesday. So we'll spend part of the period, the first 20 minutes or so, answering questions, reviewing for your chapter 1 test on Thursday. And then we'll do a little bit of review for completing the square. Because when we start chapter 2 starts out with quadratic functions, parabolas. And we'll be using completing the square for some applications of parabolas. And then chapter 2 moves on to polynomials. So it starts with parabolas, moves on to polynomials. So again, tomorrow review, test Thursday. Wednesday we'll do a little more review, and then we'll start working on completing the square and reviewing that. So with the warm-up here, we have f of x equals x plus 1. G of x is the cube root of x minus 2. It wants us to find the inverse of f with the composite of the inverse of g. That's what that actually means. Like you would say the inverse of f with the composite, because whenever something's in parentheses, you're taking two functions. That's called the composite of functions. And then the inverse of g. So, Nick, what do you think you do first?
Find the inverse.
Yeah, find the inverse of each of them. So, Nick, can you just refresh everybody with that process? What are you supposed to do to find the inverse?
So you flip the x and the y.
Good.
And then you solve.
Solve for?
Y.
Yeah, the y. So to find an inverse, you switch x and y, and I did it both the functions here, and then you get y by itself. So after you switch x and y, you're solving for y again. And then write it with the inverse notation, meaning I found the inverse. This represents the inverse of the given function. So the inverse of f should be x minus 1. The inverse of g, well, we have to cube both sides here. So that inverse will be x cubed plus 2. So those are the two inverse functions. Now what are you supposed to do? You've got the inverses. What do you do next? Eris? So you take the g inverse, which is x cubed plus 2. You plug that in to the f inverse, the inverse of f. So it's an x minus 1, now it's x cubed plus 2. So that part's the inverse of g, and then the minus 1. So x cubed and then plus 1 would be the inverse of f with the composite of the inverse of g. Kind of a mouthful there. Questions? That's like a good review of composite functions, finding inverse functions, kind of putting the two concepts together. So we are going to do more of these in a little bit. But before we get there, we're just going to do a little bit more work with inverses and functions that might not have an inverse initially. We're going to make them have an inverse, so that's what the next two problems look at. But are there questions with this problem here? So the next question says determine whether the function is one-to-one. If it is, find the inverse. And most of your homework, like that was the first step of the problem. Is it one-to-one? If so, you said yes, then you were supposed to find the inverse of the group of those questions. Some of them just wanted you to see if it was one-to-one. But then like the next group wanted you to actually find the inverse if you said yes, it's one-to-one. So to determine if it's one-to-one, we can just quickly look at the graph. I don't want you plugging this in your calculator. We have f of x equals the absolute value of x minus 2. What does the graph look like? Chelsea.
It's a V that starts on the
So she said it's a V, it's moving right 2. So over to positive 2, make yourself a little sketch. Slope is up 1 over 1, up 1, backwards 1. That's how we get the v. So currently as it's graphed, is this 1 to 1, Chelsea? No. It's called many to 1 because there are multiple x's for the same y. So it's not 1 to 1. However, next to the function, they give us an extra piece, and I believe number 67 may have had this extra piece. It's telling us to only look at the piece that is x less than or equal to 2. So the whole graph is an absolute value, it's a v. However, we only want a piece of that graph. So we're going to erase the piece that we don't need, which would be the piece where x is greater than 2 on the right side of this graph. So it wasn't initially 1 to 1. We're forcing it to be 1 to 1 by eliminating half the graph. So we just now made a function that's 1 to 1 by saying we're really looking at half the function, and we're looking at the left side where x is less than or equal to 2. So we can do that to any graph that is many to 1, where it does not pass the horizontal line test by just picking a piece of it. So it's like we're making it a piecewise function now. So now we've got a piece of the function. That piece is 1 to 1. So now that we can say, yes, it's 1 to 1 with just that left piece, we want to find the inverse. So exactly like Nick described before, switch x and y. So that first step's pretty easy. How do you solve for absolute value? Eris? Yeah, she's exactly right. You need to make 2 equations. Remember, an equation to represent each side of the graph. So one side is supposed to stay exactly the same, but the absolute value bars are gone. The other side we're supposed to set equal to a negative number, or in this case a negative x, to represent the 2 pieces. So we have it split. However, our graph only has 1 piece. So we need to pick the right piece to use that corresponds with the piece that we have given in our graph. So which piece do we want to use of those 2 sides, the left and the right, so that it kind of matches with the part of the graph that we're using? Did you know? Yeah, we want the negative side because we're dealing with the negative side of the graph. So, because initially we had 2 pieces, those 2 pieces were not 1 to 1. It didn't pass the horizontal line test. When you're creating your function and you split it apart into the 2 equations to solve, you need to only use one of those 2 equations. Both of them do not represent just the left side. One represents the left side, the other one represents the right. So we need to make sure that we're picking the correct piece. So we'll solve for, or find the inverse of the negative piece, not the positive piece. So getting the 2 to the other side, and then writing it in function notation. Questions so far? So there's one last thing that you have to think about. So these aren't just like quick, straightforward. There's a little bit of logic going on with them. If you have negative x plus 2, what kind of graph is negative x plus 2? Not a trick question. Alice, what kind of graph is negative x plus 2? Yeah, it's just a line. So this is just a line that goes on forever to the left and the right. However, my graph is not an entire line, it's just a piece of the line. And if I have negative x plus 2, right now that's an entire line. So if you go to the y-intercept of 2, we want the piece of the line that's negative. The x values, though, are increasing because it's supposed to be a reflection over the line y equals x. So this negative x plus 2, yes, we want the line of negative x plus 2, but we want the line that starts at the x value of 0 and goes to positive infinity. I can't have the whole line. I can only have half of it, essentially, or a portion of it, because my original graph wasn't the whole line. It was only a portion of it. So the reason it's from 0 to infinity is because it has to be a reflection. Well, if it was facing like kind of the other direction, it has to flip and reflect. So now it's going down. Together they end up making a whole line again. But individually you had the one line that was this top part here, and now this second line is kind of like the bottom part. Virginia. Exactly. Yes. Other questions? So we're going to try and do this a second time with just a different function. So anytime you're picking a piece of a graph, you need to make sure you give the domain of the answer so that it correlates with the piece of the graph we're choosing. So if you look at the second one, see if you can graph this, and then it says to delete the part of the graph so that it remains 1 to 1. So graph f of x equals 1 minus x squared. Without a calculator, make yourself a little sketch. No calculator required. Okay, what's this graph look like? Awesome. So you said up 1. The parabola goes upside down because of negative in front of the x squared. So something like this. Currently, it does not pass the horizontal line test. So you are asked to delete one of the sides. And you can pick a side. So Kate, which one do you think would be easier to delete? So that whatever remains might be a little easier to solve for. Yeah, I think that's what most people probably would do. Just delete that left side of the graph. Okay. So once you delete the graph, go back to the original function, just like it was listed above. Now we're looking at the problem where x is greater than or equal to 0. Because we kept the positive x values. And I know it's going down, but the x values we're choosing are greater than or equal to 0. So this is the function that we're working with to make it 1 to 1. 1 minus x squared, where x is less than or equal to, or greater than or equal to 0, because we deleted the negative side. So now it says find the inverse and give its domain. So that's going to be the part that we need to think about. So this is y, and then find the inverse. So take the 1 to the other side. That leaves us with negative y squared. Before you can take the square root, don't forget to get rid of that negative sign. Because you can't take the square root of negative y squared. You've got to divide by a negative 1 first. And then Libby, to get rid of the square, we square root. And usually, what do we put in front of the square root when you put it in a problem?
Plus or minus, but since it's hot, like it has to be plus.
Exactly. So usually you put a plus or a minus there. If Cade would have said, hey, we're keeping the negative side, then we would have the negative of this equation. If we keep the positive side, then we have the positive of that equation. So that you got those two answers, that plus or minus, to account for the two answers that should be with the problem. So there's still two sides, a plus or a minus, but we only want the plus. So our inverse function would be the positive 1 minus x. You don't need to put a plus there, but just to kind of emphasize that we're picking the positive part because we kept the positive side of the graph. Okay, so then you're asked to give the domain. So if you just look at the equation, it's a square root. What must the domain be for a square root? So we know that it has to be greater than or equal to 0 anytime you have a square root. So what kind of numbers would have to go in there then to make it greater than or equal to 0? What would the domain be? Sabrina, do you know?
This would be less than or equal to 1.
So she said it has to be less than or equal to 1, which would mean it goes from negative infinity up to 1. So if you solve the little equation underneath there, 1 minus x has to be greater than or equal to 0, that ends up saying x is less than or equal to 1. Because if you plug a 2 in here, 1 minus 2 is the square root of negative 1. Can't do that. I plug a 4 in, 1 minus 4 is the square root of negative 3. But if you plug a negative number in, like 1 minus negative 3, now I have the square root of 4. So we're looking at those negative numbers. So this graph starts here, and it actually hooks the other direction. So they should be reflections of each other. Libby?
If it's the domain, wouldn't it be 1 to infinity since it's positive, or would it?
If you say 1 to infinity, if you plug in a 2,
Yeah.
you're gonna have 1 minus 2,
Uh,
which is the square root of negative
Yeah.
1.
Okay.
Other questions? So you're thinking of the answer here with that square root. Other questions? So then the last thing we're going to look at is just combining the two together, so kind of similar to the warm-up problem. The group of problems in your homework, the 105 to 113, this is going to be similar to those problems where you're given two functions and then you're asked to do like 6 different things with those two functions. So if you just look at the whole page, there are 6 problems on here, notated slightly different. So the negative 1 is either attached to the function or the negative 1 is outside of the parentheses. And kind of just being able to recognize and understand what it means based off of where the inverse is located. What are we taking the inverse of? Are we taking the inverse of the function? Are we taking the inverse of the composite? So our two functions, f is 1/4 x plus 5, g is x cubed. And I want you to find the indicated value or function. So before you do any of the problems, what do you think would be a good idea to start off? Chelsea? Yeah, probably finding the inverses, because once you have them, then they're there for you to use for any of the equations below that you might need them for. So see if you can find the inverses of those two. And there's some like space up in the margin, so if you want to put it in that space that you have above, then you've got those two inverses to look at. Myself some space. So just be careful when you're multiplying by 4. Remember, all of the left side gets multiplied by 4. So you can either keep it as 4 times the quantity x minus 5, or you can write it as 4x minus 5. Or how about minus 20, not minus 5. So the inverse of f is either 4 times the quantity x minus 5, or just 4x minus 20. And then the inverse of g should be the cube root of x. So I got both of those inverses. So if you look at A, we have the f of g with a little negative 1 outside. So Alice inside, what does that f dot g mean?
Well, it's plug G in for now.
Right, so you plug g in for f. You're going to do that part first because it's inside parentheses. And rules of parentheses, whatever's inside you do first. The outside part is the inverse. So after you find the plugging g in for f, then you take the inverse. So kind of notice where the negative 1 is. The inverse part is last. So you're doing the composite part first. So Alice, when you plug g in for f, what does that give you?
So it would be 1/4 x cubed
Yeah, 1/4 x cubed
plus 5.
plus 5. So that part there is the f of g of x. Then you're finding the inverse of this function. This is f of g of x. So we would switch x and y and find its inverse. So we're doing the composite first, the inverse second because of where the negative 1 is located. So subtract the 5. Multiply by 4. And finally take the cube root. So we'd have the cube root of 4x minus 20. So we did the composite. We took the answer of the composite and then took the inverse. So looking at letter B, kind of notice the difference in the notation. So there are not parentheses. They're just individual separated. So this is really saying do the inverse of G, the inverse of F, the composite of those. So like the warm-up that we went over, just kind of doing the opposite. So this time you're using the inverse functions. You're not using the original functions. So the inverse of F was 4x minus 20. We're plugging that into G. So now it's the cube root of 4x minus 20, which is the same as the one right next to it. Not a coincidence. That'll happen every single time. So if you have f of g of x and its inverse, it's equal to the exact opposite, the inverse of g with the inverse of f. So what I'd like you to do is see if you can work on C and D. You're plugging in a 2 or you're plugging in a negative 1, but you're using the same function. And you can plug the 2 in first with the inverse, or you can get the inverses together and then plug the 2 in last for x. Totally up to you. But C, you're looking at the inverse of f with the inverse of f. D is the inverse of G with the inverse of G. So you're only using the inverses in C and D. And also, I think, E. I'm going to give you back your take-home quizzes. So if there's a number in parentheses, you should have a number as an answer. So working on the inside, you're taking the inverse of f and not that. Plugging in a 2, so that should be 4 times 2 minus 20, which is negative 12. And then you're taking that answer and you're plugging it back into the inverse of f a second time. So this is now negative 12. You're plugging that back in another time. So 4 times negative 12 and then minus 20. So you're using the f function twice. What's that equal to? Oh, what did you get? Negative 68, yeah. So you're taking the 2, plugging it into f, the inverse of f first, getting an answer. Taking the answer, plugging it back into the inverse of f. So if we do letter G the same way, letter G was the cube root of x. Well, x is negative 1. What is the cube root of negative 1? -1. And then you're taking -1 and you're plugging it in a second time. So again, you have the cube root of -1, which is still -1. The answer does not change. Any questions on those? So just be careful with the notation, looking to see where that negative, the inverse, is kind of applied. Is it outside the entire group, or is it connected individually to the functions? Your homework tonight, so there's a few problems in the book, working with composite and inverse functions. And then in your packet, the next page in your packet is the review worksheet for chapter 1. And I'd like you to start it, I'm going to be looking at 1 through 10. And I was hoping somebody would like to do 7 and someone else would like to do 9 from that review worksheet.